Okay guys, so again we are back into the series of Gen AI. In the last week sessions we started the discussion of deep learning with the concept of neural networks, which includes the inputs, bias, weights associated, and forward processing with nonlinear activation functions and calculating the loss with the expected output and obtained output. And then what is the next important step we done? Back propagation. What did we did in the back propagation? Calculating the derivatives to carry forward these gradients to update the inputs and biases, and repeating the process again, the forward process with the updated weights and biases until the algorithm converges and getting the optimal loss values. Right. This is the concept that we had discussed in the last 2 weeks of sessions of deep learning course by Sri Pooja Madam. Right. Now we are going to continue the course of Gen AI with the concept of convolution neural networks from this week onwards. We are moving ahead. Okay. You guys are heard about the concept of convolution neural network, right? Simply answer my question. What is the use of this convolution neural networks? Why we are using that? Any idea? There you worked with the numerical data, you just recollect it with the tensors, with the numpy arrays and tensors you worked there for calculating the forward pose and backward pose and updating the weights and the parameters all together. Okay, simply to say, what is the use of convolution? Convolution neural networks are more popular for what? Huh? To tackle complexity. What type of complexity? CNNs, convolution, general awareness, yes, simply to say for processing image data. It's a basic answer. Okay, that we are going to do. But before processing the image data using the convolution neural networks, first of all we should understand what is the image data. Let us start our journey from image, understanding the image and its representation. Okay, you have been shared a practice notebook. All of you log into Thought3 and open the practice notebook which has been shared. The title is PSCL CNN session 1 practice. All of you keep open that notebook. We are going to do the hands-on session. You have to do it simultaneously with me. Today the task is, the program is scheduled with the hands-on session along with the 1 or 2 exercises related to the concepts whatever we are discussing in the session itself. Is it clear? All of you open to the Tantric, log into the Tantric and open the notebook practice session. Will you respond? How many of you opened? Good number. The last, everyone has to do this. Okay, let's start our journey. Here in the notebook, if you open at the first cell itself, you could find out the paths to the sample images and the sample data set with which we are going to work in the today's session. Hope I am clear, right? If you don't have the copy and paste option, you have to type this entire path. Is the first cell made read only, editable? It's okay, no problem, whatever it is. If it is not read only, save it into the variable and use that variable name. You know that logic, okay? The same thing what I am doing here, you can do that. I am storing into the variable names. Anyhow, thus different images I am going to work with. The first cell, is it editable to you, first cell? Could you please confirm? It's not editable. Okay, format is it editable? I am making it simplified. Anyhow, this 1018 is not allowed with invalid variable name. I am using underscore fine. Okay, simply to say the first cell consisting of the sample image paths with which we are going to work today's session. That's it. So let us start our journey with the first image, deer.jpeg. This is the image I am going to take. Is the screen visible for all of you? Yes, deer.jpg is the first image I am going to work with. This is one image which is provided and shared and saved in this drive location which is mentioned here, shared data, dataset something something. It's a JPG image. The first thing is I want to visualize, render this image in the inline in this Jupyter notebook. Simple task. Render this image which is provided in the shared drive location inline in this Jupyter notebook. Nothing is there. Clear? Let's do this. So first, what are required? Rendering the image. In order to visualize this image inline in this Jupyter notebook, first of all I need to open that image. Correct? Read that image content and then visualization. So two libraries I need for this purpose. Do this simultaneously with me. I am going to work with matplot. So import matplotlib.pyplot as a variable plt. This is for rendering the image, and I need one more library that is for opening the image. I am using the same matplot. Import matplotlib.image as mpimg. Two libraries, matplotlib pyplot and matplotlib image. Two libraries I am using. Pyplot is for rendering the image, .image is for reading the image. Simple thing. Now what is this image path? Take this entire image path which is given to you in the deer.jpg. All of you take this entire image path. Okay, I too will take it for your convenience. Done. So this is the image path which I wanted to read and visualize. Done. Now the path is there with me. Now this image is to be opened and read. I am having the library variable mpimg. With respect to mpimg, I am going to read this image with the method imread. How many of you know this concept? Could you please raise up the hands? How many of you know this concept? Reading an image. Okay, one or two. Okay, rest of all learn it. For today first session, let's start with the very basics. So very basic things are very important for us. Okay. So I am reading this image with the variable library which I imported mpimg with the method imread. So what is supposed to be passed to this method? That image path which we have taken, and I'll store it into the variable image so that I open and read the image. Done. Okay. Now I wanted to see this, what is there in this image. That's it. Just print image. What can you observe? Can you see here? What is this result? Come on, speak out. What is this? It should be interactive only. NumPy array. Correct? That image was read as a NumPy array. Fine. What is the shape of the image? Just have a look at this one. Call the attribute shape attribute of this image. What you can see here? What is this? What is this? A 3D NumPy array, 3-dimensional NumPy array. What these three values are representing? The first is what, second is what, third is what. This what we need to understand. Okay, right. Let me show you display, render that image. I read the image using mpimg imread method. Now I wanted to render or visualize this image inline in the Jupyter notebook. For this I am using plt library. plt.imshow is the method which is used to render or visualize the image. Okay, so my image is in the variable image which is already read. Okay, that's what I am doing here. What you can see here? A small deer image. All of you got it? Now just have a look at this. You can observe the axis displayed along with this image. See it vertically 0, 50 and so on, 200 and something, and horizontally 200 and only 1 or 2 positions in the x-axis. Meaning that now try to understand what is this one. When you see the shape of the image data, it is a 3D NumPy array, which is the first one is first dimension is height of the image, second is the width of the image, number of pixels vertically, horizontally, and then what is the third one? Sorry? So what is the third one? So first two dimensions is clear to you, right? What is the third one? Right? So this is the color image you can see here. Let me tell you how these color images will be represented. It's a color image, nothing but RGB representation of the image. Colored image is a combination of 3 channels, red, green and blue. It's a stack of 3 channels, red, green and blue, you can see here. Let's assume this is the pixel image with 5 pixels height and 5 pixels width, you can see here. So that there are totally 25 pixels which are indexed from 0 to 4, both horizontally and vertically. If I wanted to access the 25th pixel of this image, this is nothing but this one. Its index position is 4 by 4. What it is representing is that particular corner position of the red channel, stacked behind is the green channel, behind is the blue channel. These 3 channels together of that particular index position pixel values. What are those? 24, 23 and 34. This is a 3 element array. Is the pixel value of this particular position, index position 4, 4. The same you can see from this NumPy array, this is the position 24, 23, 30. Now tell me what is the third dimension 3? When you are looking at the shape of a colored image, channel representation, RGB channel representation. Is it clear? If it is a color image, when you are reading the color image data, you will get it in a 3D NumPy array. First 2 are height and width, this you have to remember while going on into the CNN. Height, width and the third is the channel. If it is a RGB image, because it is a RGB stack of 3 channels, you will get the channel values 3 for color images. Is it clear up to this point? Okay, let's move back to this part. Okay, small things are also there. Here the axes are getting displayed. I don't want that axis to get it displaced. I can do that in a simple thing by setting the plt.axis is off. Done? Okay? Yeah. If I did so, I got some information here, you can see here. Related to the image object, some additional information when you are rendering the images would get displaced. If you don't want, in some editors, even this IMShow method itself of matplotlib library cannot render the image. It will create the image but will not render. But for this environment it is working. In some environment it will not work. In that cases you need to instruct this PLT library to render the created image. That you are supposed to do with additional plt.show, calling the plt.show method. This is optional in this case, but whenever required, learn it. Whenever it required, you are supposed to use in such a way. So now it is a perfect way of visualization. Is it clear? Understood about the color image? Okay, now let us try with the grayscale image. Okay, grayscale image. Take the image path. So the grayscale image here itself is this one, 1018. An image with the name 1018 is there, na? So copy this path and paste it here, or else you have to type this entire path. I'll wait for a second. Please remember that, be careful about the entire path location /srv shared data datasets DL3, deep learning DL3, PSEL CNN assignment underscore 192 /1018.jpg. Okay, this is another image which we are taking. Right. Now again type, let it be practice for you. Image equal to, I am reading this same method, mpimg.imread of this image path. Once the image is read, I wanted to print the shape of the image, and I wanted to visualize or render this image, plt.im show of that image. Can you see what it is? What are you getting? Looking at the shape, what you received? 150 by 150. Is it different from the earlier one? How? There you got 3D numpy array. The third one represents a channel for color images. The value is 3 because it is RGB, stack of 3 channels. But for grayscale image, black and white grayscale image, we will get only 2 dimensions. What this 150? Height and width only. Clear? For grayscale image, there is no channel information will get displayed. If it is there, it would be 1. Correct? That is nothing but grayscale, shades from black to white. Okay, right. Now, did you observe anything here? How this image is looking? It's not exactly the black and white image. I said it is a grayscale image, but it is not the grayscale image. Remember. So, the method that we use for showing or rendering this image is plot library imshow. When you are using this function and this library, matplotlib library for rendering the images, for grayscale images, it will use the color mapping of Viridis. This is called Viridis representation, which is nothing but the mapping of the image data to the colors. Look at into the picture, green to blue to, sorry, what is that? Green to yellow to blue color likewise is there. That is called Viridis mapping, color mapping of image data. When you are using the matplotlib function imshow for rendering the grayscale images. This is the reason why it cannot capture and shows effectively intensity of the grayscale shades. So, you need to instruct the matplotlib library to capture the exact intensity, pixel intensity values which matches the grayscale representation of black and white shades. How can you do this one is by setting the CMap attribute, CMap variable to gray in the imshow method of plot library. Just do it. Can you see the difference? This is exactly grayscale image. How many of you completed till this part? Raise up the hands. Very less number. What about the last? It seems to be so simple, but if you do the practice, then only you will be familiar with these concepts. Going deeper, we are stucking at this level only. You just do practice for 30 minutes only. Already 10 minutes over, no problem. Okay, now the task for you is, I want to add an additional channel to this image. For this image, it is a 2D numpy array. I wanted to make it as 3D numpy array by adding additional channel. Because it is a grayscale image, channel value could be 1. It's not a color image. If it is a color image, third dimension channel should be 3. Because it is not the color grayscale, channel should be 1. How can I do this? Can anyone help me? This image variable, IMAGE, image is a numpy array with 2 dimensions. I want to extend the dimension. Got my point? Getting my point? I want to expand the dimension of numpy array. That's it. Simple. Take it. Take the command line. Add channel information to the gray image. Getting? So, image, gray image with channel. I need this one. It's simple. This image is a numpy array. I wanted to expand the dimension. There is a function called expand dims from the numpy library. So, I am importing numpy as np and I am using this np dot expand underscore dimension dims, for which I wanted to expand the dimension. For what? What I supposed to pass? For image. Yes, image. Okay. Where I wanted to expand the dimension? Vertically or horizontally? Vertically. So, axis equal to column, axis equal to 2. Now, just to display this, print gray image with channel dot shape. Yes, I did it. You understand what I did? I just read a grayscale image using the matplotlib library. So, I got the dimension is 2 dimensional, height and width only. Because it is a grayscale, no channel information. I am intended to create a grayscale, I mean channel for this image. For that numpy array, the dimension vertically is expanded. Now I got this. Now one more task for you. Can anyone convert this image into the color image? Technically. Please catch my point. Technically, yes, somebody is trying. You just think, not possible? Yeah, 3 channel. If it is a color image means you should get 3 channels. How can you? Can you do it or not? If you capture a black and white image using a color photograph also, still you will get the black and white image only. Seems to be black and white, but technically used the color photograph, color camera. Same similar like concept. Mine is the black and white image, but I wanted to make it technically as a color image. Simply to say, I need this third dimension should be 3 instead of 1. Can I make it or not? Maybe. Okay, I can do it. If I repeat this gray channel 3 times across the third axis, getting my point? Simple logic. If I repeat that gray channel 3 times across this axis, I can do it. That's what I am doing. So, RGB image I am going to get with np dot repeat is the method. I am repeating. For what? Will it be image or gray image with the channel? Gray image with channel. Okay? With the added channel I supposed to. Gray image with channel, comma 3 times access equal to 2. So that I would get RGB image. Now let me display this RB image dot shape. Okay, I got it. How it is different from the original image which I took at the very first step of this grayscale image? Okay, we will see what is the meaning of the thought channel. If we look at the thought channel information, obviously we will get some idea, right? Okay, print RGB IMG. Can you understand anything looking at this numpy array? I can do the same thing with the slicing and keeping the first dimension height as it is, width as it is, but the channel information is 0. What does it mean? Here is the channel, is the 3 values are there, a stack of 3. From 3 I am taking only 0th dimension. What does it mean? Can anybody? Okay, we will see what it will visualize. Just have a look at those values. Okay. Again take the same thing and change the channel index 1 and see the values. And again take it the same thing and look at the channel index. This is 2. And check the values of this resultant numpy array image data. Looking at these 3 results, you can come to a conclusion. What does it mean? Here what I displayed, what I visualized, red channel information. Am I correct? Red channel information of the image data was visualized. So what is this one? Green channel. And what is this index 2 of the channel position? Blue channel. Looking at all these numpy arrays results, I mean the image information across these 3 channels, the values are similar, whatever is visible for our region. What is the meaning? For the first image, just move back. For the first image d.jpeg, when you visualize this image numpy array, you had observed different values across RGB channels. Okay, we'll take the same example. If it is a color image, you can see the different pixel intensity values across these 3 RGB channels. So combination together is giving the color pixel representation. Now here also you are getting 3 channel information RGB, but the intensity is the same because I repeated across all the 3 channels, which is closer to the shades of white and black, giving the illusion of black and white image, grayscale image. You understood that? Technically it is a color image but seems to be gray image. Understood the concept? Guys? Okay. Let me take you to the another example. You have another image circle.jpg, right? In the first cell, look at here, take this path. IMG path equal to circle.jpg. Again do the same thing. Image equal to mpimg.imread. For your convenience, for your practice only, I am tapping again and again. I am not copying, only the path I am taking. IMG path, then plt dot I am show of image and plt dot, sorry, not plt, printing this image dot shape. What is this image? A circle shape. And looking at the dimension it is returning, the shape it is returning 3D numpy array. Height and width of the pixel, and third is the channel information 3, meaning that it is a color image but seems to be like a grayscale. Similar way how we did here, do the same process to look at the channel information for this image now, so that you can understand very clearly. Print image of slicing the height, width as it is, and the channel information is green channel, sorry, first is the red channel. What you are getting? 255. What does it mean? For grayscale representation, what is the range? This is 1. 0 is pure black, 255 is pure white. In between values are the shades, corresponding shades. Okay, now coming back to our picture, outside of this circle is totally white color. So the pixel value should be 255. In the middle of this numpy array across this particular shape only, you have to get the values close to black color, correct? So that's what I got it. So with this, because I cannot display this entire numpy array information here itself, I could see the value of 255 only which is surrounding the shape. You understood what is that? Outside pixels of this shape are white color. Okay? Even if you change this dimension, what is that, channel information to the red channel or else blue channel, you are getting the same values. What does it mean? Even it is color image, but the pixel intensity values are same across all the RGB channel. The pixel value is close to the black and white colors. Understood that? The color and black and white images with the channel representation. Any doubts up to this point, guys? Okay, I am moving to the next step. Okay, right. This image, I want you to illustrate this image, how it is to be at this particular positions of this numpy array. Fine. As I cannot visualize the entire numpy array and n-dimensional array, I wanted to reduce the size of this image first. The task is, I wanted to resize the image. Is it necessary to resize the image? Do you need of the concept of resizing images? Where do you need? When do you require? Do you need of the concept resizing of images? Tell me. Why we need to resize the image? Okay, look at this. This is the one image with the size 166 by 172. Okay, look at the first image. This is of size 150 by 150. Another image which is of size 240 by 250. If we are working with a bulk of images for your machine learning algorithm, whether it is the classification or something, you have to handle all these images in a similar way, correct? When you are converting into the suitable format for the machine learning algorithm, you need to fix the size of the image for all this collection of images. There you need the concept of resizing of images. Fine. Okay. So resizing is nothing but the transformation. Fine. Now I wanted to reduce the size of this image to 28 by 28 pixels compatible. Can I use resize image equal to image dot resize for image dot resize with the resized dimension is 28 by 28. Can I try this? Anything wrong in this one? Seems to be nothing is wrong. Image I have, this I wanted to resize. Resize method I called up with the required dimension 28 by 28. Okay, let me try this. Can you see the error what I am getting? Try out and tell me. Cannot resize this array. It does not own its data. How you are reading your image using the matplot library? How it is reading the image as a n-dimensional array? This resize is a method not defined to n-dimensional array. Okay, that's one. And this n-dimensional array representation is the view of another array. That is the reason why you are getting the error message. It's not own its data. Now how to resolve this issue? You can create a copy of this image. For that copy you can apply this one. That is one method. Shall we do that? Okay. Create copy of image. img copy I am creating. np.copy is the method I am using for creating the copy of the image. Yes, I did it. Now for this copied image, I am going to img copy, calling this resize method by specifying the size which I wanted to do. I am storing into the variable resized image. Now this resized image shape I am going to get display. Because it is being converted into the fill image, now you cannot use the shape attribute. You can use the size attribute. Size is not readed for me. So what I am supposed to do again is, image is to be converted into the array. For this np.array of resize image. Now this image array I am going to display. What happened? Let me run back this part where I read this image. This is my image. Okay. I am copying this image. None type attribute has the shape. So if I use this size, no, I am not getting this one. Image. dot copy of image, or else I'll try another method. Think something is missing. Resize of this one. Okay, let me try once. Image array, np dot array. Think we supposed to call np dot array is correct. From array also we can use resize image. Then resize image is be I'm going to display image array. Image array dot size and array dot shape. No, it is not giving the shape. Okay, I'll try another method, that is using, okay, I'll convert into the PIL image. From PIL import image, then get the PIL image. I'll see what I'm missing there in that in a while. Image dot from array image. So using the from array method of image library from the PIL, I'm converting that image into PIL image. Now this PIL image, okay, yes. Now for this PIL image, I am applying the resizing. PIL image dot resize of, what is the size I need? 28 by 28. Done. Then print resize image dot size. Okay. So I think I'm missing something in creating the copy. I will find out that issue. So one method is creating the copy, converting this image into the PIL image. Instead of NumPy array, we are converting it to the PIL representation. For doing so, what we need is, we need the PIL library. From the PIL library, we have to import the image. With respect to image, call the method from array and pass this image which you wanted to convert into the NumPy array of the image which you wanted to convert into the PIL image. Once it's been converted, then call the resize method with the specific resize dimension that you wanted to apply. But because this is the PIL information, not the NumPy array, you can't call the attribute shape. Size only you can do this. Okay, this is not preferable. What you are doing, your intention is resizing the image. This is what called the transformation that you are applying to an image. Is it clear? Transformations that we are applying to images. Going onwards, we are going to work with the PyTorch only. I am moving into the PyTorch. I will make you to move into the PyTorch from here onwards. Right? So, in order to do the transformations or the modifications to the image data, we will use the torch library transforms which we need to import from the torch vision library. Do it. So I am using, what I am doing here in this code cell is applying transformations using torch transformations. Okay. So from torch vision import transforms. This is the library which we are going to use. From torch vision import transforms. Now the transformations we are going to apply on the images. So still I am having my image in the variable image only. That's what I am using even now. So what is my intention? I wanted to resize the image. So how can you define the transformations using the torch transformations is transforms dot, call that particular transformation method For resizing, this is the method supposed to use. Resize or capital. Transforms dot resize. Within the parenthesis specifies the size of desired size of the image. 28 by 28. This is how the transformation should be defined and store it into the variable resize. This is the resize transformation which I define using the torch vision transforms library. Am I clear up to this point? Anything missing here? Fine? Okay. Now this resize transformation to be applied to my original image in order to reduce its size to 28 by 28. Okay. So that pass this image, our image, intended image which you wanted to resize to the defined transformation called resize and store it into the variable resized image. Done. Yes, we resized the image. Once it's done, just display this information whether how it is resized. Resized image dot shape. No, it is the tensor. Okay, shape. Because it is the tensors I am using, I'll get it. Unexpected numpy array. Remember this one. In order to apply the transformations using the torch library to the image data, first of all that image data to be converted into the torch tensors. You studied about the torch tensors in the previous sessions, like the numpy arrays, which is the main important data structure which is flexible for loading and processing the images for machine learning algorithms when you are working with the PyTorch framework. Okay. The first step is data, image data to be converted into the torch tensors. So before applying this resize transformation using torch tensors, first of all I should convert this image into the image tensor, which is also a transformation from the torch vision library. So I am defining this transforms dot to tensor is the method. T and T are capital. You need to catch up this one. Transforms dot to tensor is the method which transforms the image data into torch tensor. This is supposed to be applied to the image for my original image, so that I will get the image tensor, img tensor. Now the resize transformation is defined and stored into the variable resize. Now pass this, instead of image, pass this image tensor to resize transformation which is defined and displays the resized shape. Yeah, transforms spelling is missing, torch vision transforms here, okay, here is the missing, transforms. Check the spellings, transforms, fine. Are you getting the output? Look at this. What is the torch size returned? 3 dimension. But first is 3, first dimension is 3, next 2 are 28 by 28. 28 by 28 is my resized image height and width. What about this 3? Channel representation, because it is a color image. But when you convert this image, read the image and convert the image into torch tensors, the channel information come to the 0th index position of this numpy array. Now what is this notation? Channel height and width. But for initial images we have seen width, height and height, width and channel. But right now you got channel and height, width. Did you find the differentiation? How many of you reached up to this point? Raise up the hands. Very less numbers. Now you are going to have one exercise. Fine. Now the task is, one more thing you are going to learn. I want to reorder this dimension of this torch tensor. Why do I need to do that? Okay, let me try. This is the image I am having. What is my image name? Res image. Okay. This res image I wanted to visualize. plt.im show of this res image, resized image. What is the error, type error I got? Invalid shape 32828. Because for PLT library you need the shape 28283. Channel should be at the last position. So what I supposed to do? I want to reorder the dimension of this image tensor. Correct? So I supposed to do before this IMG tensor, sorry, not IMG tensor, my resultant is resultant image, resized image. I am updating this resized image to reorder the dimensions. Permute is the method, permute is the function which will reorder the dimensions of the torch tensors. What is the order now you need for this torch tensor? Channel should be at the last. So index positions you are supposed to specify. Instead of 0, 1, 2, which is right now 3, 28 to 28, I want the order 1, 2, 0. Am I clear? Meaning that height, first index position height, then width, and the channel which is at the 0th index position should be shifted to the last one. So permute is the torch function which will be helpful for reordering the dimensions of the torch. Now see how it is showing. Now the error gone. Fine. Okay. And next one more thing. Okay, this is the black and white image now. So let us apply the same information to this color image. We will see for color images. I will take the deer image once again, this information. You can do edit in the same code cell itself because it is a practice notebook only. So take the deer image itself. Reading the image and then applying these transformations, whatever the transformation that you have defined the same way. Okay? Okay, we will do it for the same image. What is the need of doing again? Done. This is one transformation you have done, converting into the torch tensor, and the second is resizing is done. It's already grayscale image, so you can't do this one. I wanted to show you another transformation, so I am taking the same color image, deer image. Okay. Don't get confused. I am taking the deer image once again for showing one more transformation, that is called grayscale. Because for this one I need the color image, I took the deer image once again. So image.mpim read, and once this image is read, the next step is converting into the image tensor. So transforms dot, we already defined this. For your convenience I will redefine all the libraries once again here. Import matplotlib.pyplot as plt, import matplotlib.image as mpimg, and import torch vision, sorry, from torch vision import transforms. Okay, now image it from transforms dot to tensor. I am applying, converting this image into the image tensor. Now for this image tensor I am defining the resize transformation with the size 28 by 28, and resized image I am getting by passing this resize to this image tensor to this resize transformation which is defined. And then one more transformation I wanted to apply. That is the reason why I took the same imaging again. What is that? Is grayscaling. How to define the grayscale transformation using the torch vision library? So for this transforms dot grayscale is the method supposed to use. Okay, thus gray transformation is defined. Now this gray transformation is applied to get the gray image, gray of resized img. Now once this is done, I wanted to print the shape of the gray image, and plt dot I am show rendering the gray image as well. We know that this deer is a color image. So what I did it here, just look at here, I am using the torch tensors transforms for applying the transformations on the color image. The first transformation is the red image which is created by reading the image was converted into the torch tensor. So the variable is image tensor, img tensor. Now resize transformation is defined using the torch vision transforms, and resize is applied to this image tensor so that I will get the resized image. Now this grayscale transformation is defined from the torch vision transformations, which is called as gray. This gray is applied to the resized image. Okay, finally I am trying to visualize the things. What I got? Anybody tried? What I got? Error message. Image is not visualized, rendered. What I supposed to do? Read? No, invalid shape 12828. Dimension to be reordered. So permute bit to be called up. Okay. So while showing the image itself, here I can do this one. Permute for reordering the images 1 to 0. Is it sufficient? Okay, let us see. What did I get? Virid is representation of color mapping. I didn't get the exact grayscale image. What I supposed to do? In IM show of PLT library, set the are you following me? I took the color image applied the transformations and I wanted to convert into the grayscale image. I had applied the transformation, but I didn't get. I got it in a Viridis representation, C map, that's it. So in IM show of PLT libraries, specify the C map variable which is equal to gray. Done it. Got it? If I don't want these axes to get displayed, I already told you, axis is turned off. You got the shape of the image? Done? Okay. So till now, guys, till now we started the discussion of learning how the image will be, how the image data will be. It's a 3D NumPy array if it is a color image with the third dimension is representing the channels RGB 3 value. And if it is a grayscale image, you will not get the third dimension, only 2-dimensional array, you will get height and width of the image. And introducing to the concept of torch tensors, the images should be first converted into the suitable format of the machine learning algorithms, that is converting into the torch tensors, then applying the transformations. In order to, there is a huge set of transformation. I just introduced 3 transformations, converting into the tensors, converting into the grayscale and resizing. So all these things you can do it from the transforms library which is imported from the torch vision. Done with this? Now a small exercise I am going to give it to you. You need to finish up. That's need only 5 to 10 minutes. 5 minutes, not more than 5 minutes also. Can you release the first exercise? Yeah. Now Mr. Pranay is going to open the exercise for you. That is the first exercise. So you just open all of you. The first exercise, everyone need to submit that. First assignment. PSEL CNN assignment 1. Applying sequence of transformations. Now listen, one point I should tell you. Till now we discussed and I shown you how to apply the 3 transformations, converting into the torch tensors, applying the resizing and also grayscaling using the torch vision library. Now the thing is, how I did it, you just recollect, check it back once again, look at that slide. First image is taken and converted into the tensor. Next resize transformation is defined and that is applied to the previous result, so that you got a new output, that is resized image. Now again one more transformation is defined, that is gray transformation. Now the previously obtained output in a sequence way, pipeline process, one after another, I had applied individually. Instead of that, there is a beautiful facility is there in torch vision library from the transforms only, that is called transforms.compose is the method. .compose, C is capital, remember. You already imported the required library for this one. From torch vision import transforms. Transforms.compose is the method which helps you to create a pipeline of transformations which you wanted to apply one after another to an image. Look at here how you write this, define this. Transforms.compose, C is capital. Within the parenthesis, list of transformations to be passed. How to pass? Transformation 1, TR1, comma, TR2, comma, TR3, likewise, number of transformations. You just define all the transformations, whatever you wanted to apply to the images in the using the transforms.compose method and store it into the variable, some variable tr like, and finally to get the finally transformed image, you are supposed to apply these transformations which you are defined to your original image. That's it. Got it? Now do the exercise. Now you can connect it. I think we need to resize it now. Multiple transformations to an image and visualize it. Two things: applying transformations and visualizing. Okay? So here itself in the problem definition, what are the transformations asked? One is the resizing image to the 150 by 150 and converting into the grayscale and applying 35 degrees random rotation. This is not yet discussed in the session itself, but I gave the instruction and the clue how to do that transformation. And finally converting into the tensor, that is the common thing. 4 transformations been asked. So define all these type of transformations using the transforms.compose method. Do that. And it is asked to import the required libraries as well. I didn't included any libraries. You have to do from scratch. Come down. So load the image of the given file path. For which image you are supposed to apply? Tiger cub is the image. The path for this image is provided in your notebook itself. Take the copy of that image path. Okay? It is provided in the practice notebook itself. Take that path and use the same path in this assignment. So first grading exercise is applying the multiple transformations to the image. And one condition is given is ensure the final image variable name should be labeled, or the variable name should be image underscore tensor, because test cases was written to validate that. After applying all the transformations, the final image variable name should be image underscore tensor. Remember that. Only one part of course cell. Second part myself is given, visualization. Both the original image and transformed image. You just have to run that. But the test cases was written to validate your code according to the instructions given. Very, very simple exercise. Everyone has to submit. Yes, 2 submissions. Total 6 submissions and
5 has got 100 by 100.
5 gradings are good. Okay. Tejasvi, try again. Just opening the notebook and submission is not the right way. You have to attempt it. Do practice it. See, I am telling you with my own experiences, we are doing at the higher level of image processing and everything, but we are failing at the very basics of applying these transformations, permute and getting the shape, getting the visualizing and rendering the images at the axis levels. All these things we are failing. If you practice, you will get it. Use the sessions for that only. 70 students, right? 70 students logged in. It's very simple exercise. You can finish off in minutes only. Do it everyone. I need all you 70 members who logged in have to submit this. Only it is asked to define all the transformations which are listed as a pipeline of transformations using the torch vision library. Transforms.compose is the method you are supposed to use. I had shown you how to use that also. The thing is, whatever is done till now, importing the required library for opening the image or reading the image and rendering the image, and for applying the transformations, these libraries should be imported. And define the transformations, all whatever is listed to be applied to the image should be done using the transforms.compose method. and the rest of the part is simple. Read the image. So it is asked to choose the image tiger cub, and only the constraint made is the final image after applying the transformation should be labeled, or the variable should be image underscore tensor. I can help you. Once you understand the basic things with the simple exercises and the practices, it will be easy for you when you are working with a huge and a large data sets. You will never stuck into that. You just follow the instructions. It's very simple exercise, but you are taking much time. Finish it off fast. We'll move to the next topic. Very interesting, very important for you. Moving onwards is very, very important and crucial things. Okay, we have seen JPEG image. DIR is the JPEG image. Then JPG image. What about PNG image? Let's back to this. Meanwhile, whomever completed this exercise, submitted this exercise and graded well, back to the practice session. There is one PNG image is there. What is the name of the PNG image? 5. Okay. Use that PNG image, read that image and see the shape of that image. See the shape of that image and tell me what you are getting. 4. Height, width and the third dimension you are getting 4. What does it mean? I said for color images you will get the channel. Third is the channel number. Because it is a color image, you will get the channel value is 3. If it is a grayscale image, only 2 dimension. Even if you get the third channel, it will be 1 only. What about this 4? PNG images will have an additional, that is called transparency of the image. Its mode is RGBA. Color images is RGB. PNG images you will get RGBA. So whenever you are working with the PNG images in your data sets going onwards, you have to take care about this one. Fine? Now I need all the 60 submissions. Do it fast. Till now only 53. The strength is around 60 to 670. Finish it off all of you. Tejasvi, your notebook grading is still 0. Who is this Tejasvi? What is the problem? Are you facing any problem? But its grading is 0 only? Okay, submit. It makes you perfect. You have to do it. Otherwise, no use of learning and listening all these things. Until and unless you are practicing. Practice, practice, practice. The thing is, after going home, once again you have to do all these things from the beginning. Then only you can remember. Can you raise up the hands who haven't yet attempted the exercise? Be honesty, no problem. I just wanted to see those gems who even didn't attempted this exercise. Guys, who are those germs in this class? It's 56 only it is showing, but the strength seems to be 60 to 70. Okay, out of 56, 53 graded. Okay, with that exercise, tell me what you learned. Compose. Okay. Torch vision transformations. Defining transformations using torch vision library. How to define a sequence of transformations and applying transformations. Up to this part. Is it worthy of learning the concept? Very good. Let's back to the practice. I'll introduce the topic of the next and we'll stop. Sharp by 6 o'clock. Let's back to the practice session. You have been provided a path to a sample directory of images at the very beginning of the cell. Could you please look at sample data set? What is its name? Anim datasets. Take that path. Okay, till now we have seen how to work with a single image. Just listen and be focused. We have seen how to work with a single image. Now we are moving on to the next step, working with the bulk of images, directory of images. Right? Let's moving on to this. Here you have been provided an image directory which is named anim faces, animated image faces. That's it. Nothing is there. Okay. This what we are going to work with. What is there in that directory? Let us see first. Will this command ls work, Mr. Pranay? ls. We'll see. No, it is not working, correct? Okay, no problem. So I want to work with these images. That is what I am trying to do. I'll try with this one, anim faces. Okay, guys. Now the task in front of is, this is the directory or the folder which is consisting of some images. We don't know what is there in the directory. I can't show you here. ls working for you? But why it is not working? Whole path, na? Okay, fine. Okay, let us see. ls of this entire path. Quotations we can't give, na? Okay, fine. Will you look into this one? What this anim faces folder consisting of? Glasses and no glasses. What are these? Let us see what are those also. So two subfolders are there within the anim faces. One is glasses, another is no glasses. Within the glasses, if you list out, you can see the JPG images. How many images are there? 5 into 3 rows. 15 images are there in the glasses, and similarly if you see 15 images are there in the even no glasses. What does it mean? Can you tell me how this data is organized? Anim faces is the directory which is consisting of two subfolders. One is the glasses, second is the no glasses. Each is containing the sample images of that particular class. The subfolders are nothing but the classes of the image. Animated faces wearing the glasses and animated faces non wearing the glasses. Is it clear what is the data is? Okay. Now listen. If the data is organized in such a way, main folder consisting of subfolders which is labeled, which are nothing but the names of the subfolders are the classes of the data. Within each subfolder, the sample of images related to that particular class. If the data is organized in such a way, there is a beautiful library provided in the Torch Vision datasets that is called image folder, which helps us to read and load the images which is organized in a folder and subfolder which are labeled as the classes. Understood the point? No? Let me tell you again. You just have a look at this, how the data is organized. I had shown you this one. Once again I am telling you. This is the image. This is the directory which I specified to you. Anim images, anim faces is the directory. How this directory is organized, that is important for you. You can do the CNN, convolution neural network, for different varieties of tasks. For example, classification of images into one or two or multiple classes. Generating the images while working with the encoders and GANs. From the existing images, we are going to generate the images. Is it clear? Just consider these two scenarios. Fine. See, in the first case of scenario, you need the data collection for training your neural network with the images which are of each class. It's a classification task. For the second case of image, new image generation, do you need of the classes? Bulk of images in a folder is sufficient, na? Getting my point? So, when you are working with the task, specific task of CNNs, I mean the image data, you have to look at how the data was organized. Here in this case, I am giving you one data set and asking you check how the data was organized. This anim images faces is the data which is organized into two subfolders. One is glasses, another is non-glasses. Within the glasses, what is there? I just told you to check. What are there? Images. 15 JPG images are there. What does it mean? These are all the images which are animated faces wearing the glasses. Similarly, no glasses. I can show you by rendering the data set. Similarly, there are certain sample of images under another class, no glass. What does it mean? Animated faces which are not wearing the glasses. Now you have the bulk of animated faces into two subfolders, glasses and no glasses. Under each that particular category of samples, well organized data, best suitable for the classification task of whether the animated face is wearing the glass or not wearing the glass, classification task. Now the point is, where this data is provided in the disk location. Now you have to, when you are working with the model, you have to create your own image folder which is suitable for the machine learning algorithm. Data set is to be created. In order to create the data set, which is such a well organized into main folder and subfolders which are related to the class labels, then there is a beautiful library which is provided, that is called image folder. Passing the directory path to this image folder anim images. What is the name of this directory? Anim faces. You can create the data set. But where this image folder is defined? Which library? Datasets library of the Torch Vision. Correct? Done. Very good. I am importing this from Torch Vision, import datasets, please remember. Now datasets dot image folder is the method supposed to be called up. That's it. So in order to create the data set from the data folder, which is such a well organized into the main folder and subfolders related to each of the classes, within the subfolder the data relevant to that particular class. Such type of file structures will be well organized and handled using the Torch Vision library called image folder. I and F are capitals. That should be imported from the Torch Vision datasets. Missing datasets, correct. Please correct the spelling mistakes if any. Datasets. Done. Once it is done, just display the data set. Enough. How many of you done this part? Raise up the hands. Last, guys. You have to finish off. Do this. All of you do this. Take the anim images, anim faces directory path and create the data set using the image folder. Yes. now I am able to create my data set perfectly. What is there in this image folder data set now? 30 data points are there. What are these 30 data points? Images which are in individual subfolders of glasses and no glasses. Let us see. You just type dataset dot samples. Just have a look on this one. What you can see here. Dataset dot samples. You can see all the 30 data points as a list. What is this list consisting of? That you need to understand. It's a tuple with the image, first data point, which is a JPG image along with the entire path. Remember what I am telling here. Tomorrow you are going to face an exercise. There you are supposed to answer this one. So listen carefully what I am saying. When you created the data sets using the image folder library, image folder method, it will create the data samples. It is a list of data samples. Each sample is a tuple. Look at here, parentheses are there. What is this tuple consisting of? Data point. Here it is the image, JPG image along with the entire path. I am stressing this again. Along with entire path. From the root directory, look at there, /srv. Followed by what? For the first 15 samples you are getting the label is 0. For the last 15 samples you can see the label is 1. What is that? Directory name, nothing but class. Target variable. To which class that data point belongs to. Now your data is ready for training purpose. Both the input and the target together. A pair of input and target. Is it clear? Okay. What are the other attributes that you can see? Dataset dot samples I told you. Dataset dot classes. See this? You can see the name of the classes using the dataset dot classes attribute. If you use the dataset, if there are multiple classes are there, you may not remember what is the index for each class individually. So that you can get it from class to IDX. So it will display the list of all the classes with the corresponding index number, so that easily you can catch up the what is the meaning of that label 0. It is representing the glasses. Label 1 is representing no glasses information. Okay. I think I will stop it here itself. Tomorrow we are going to continue from here itself. Okay. Right. Thank you all.